Welcome everyone. My name is Robin Clark, and this is the introduction to the Quick Start Guide series. There are several Quick Start Guides. The purpose of the Quick Start Guide is to get new users quickly familiar with ExtendSim and knowledgeable about its features and capabilities. This guide is broken down into 5 chapters. This video is Chapter 1, the introduction. In Chapter 2, we will learn the basics about how to build and run a model, and we will discuss the concepts of a model. In Chapter 3, we will go through a tutorial to build a simple model. In Chapter 4, we will expand the model that we built previously in Chapter 3 to reflect the entire system. In Chapter 5, we will cover basic concepts and terminology. Discrete event simulation is the methodology used to simulate the behavior of a system of processes in which events, rather than the mere passing of time, causes changes to system components and hence to the system. In a DES model, nothing happens between points in time until events occur. At each event, the status of the system components, such as entities and resources, is recalculated and the state of the system changes. Typically, discrete event models involve a series of queues or activities or routing or resource functions. Processes are organized around events, such as the receipt of parts or the request for service or the ringing of a telephone. Events occur at random but somewhat predictable intervals and can be economic or non-economic. Discrete event simulation is indispensable for understanding, analyzing, and predicting the behavior of complex and large-scale systems. It is used to ensure that the functioning of existing systems is well understood and that the design of new systems is efficient and beneficial. Discrete event simulation models allows companies and governmental agencies to look at their fundamental processes from a cross-functional perspective and ask why or what if. This gives some of the most common areas where discrete event modeling is used. This includes manufacturing, the service industries, communication and network industries, and the transportation and material handling industry. Here is an example of how a discrete event model in ExtendSim was used to redesign an emergency department. In addition to other factors, the model included daily patient volume, arrival profiles, the emergency severity index probabilities, diagnostic probabilities, service times, and more. The insight gained from the analysis helped guide the design of the new department. Let's take a moment and compare discrete event with discrete rate and continuous. In discrete rate and discrete event models, the time steps are not fixed, and the state changes when these events occur. In continuous models, the time steps are fixed, and the state changes when the time changes. Discrete event models individually identifiable things. Continuous and discrete rate models homogeneous stuff. Both discrete event and discrete rate models have the capability of modeling attributes. Continuous models do not have the capability of modeling attributes. Both discrete event and discrete rate models have the capability of ordering or prioritization. Continuous does not have the capability of ordering or prioritization. This concludes the first chapter in the Discrete Event Simulation Quick Start Guide. In our next chapter, we will cover the model basics. I hope you will join us there as well.